All right, good evening, everyone. Going to go through and do a walkthrough of basic data screening for a one-way ANOVA. So the data that we're going to be using, the worksheet we're going to be using here is the one from class, the one-way ANOVA screening from in Stata, and so we're going to be looking for the one-way ANOVA data set here. Recall from the example in class, what we're doing is we've got a film clip that's intended to elicit positive emotion, and we're wanting to see whether or not this experimental stimuli is working similarly for individuals from different racial ethnic backgrounds. We've got a diverse sample, so we have individuals who are identified as white, non-Hispanic, black, non-Hispanic, and then an other category that's less interpretable, and so not good science, but will work, I suppose, for our purposes here. Viewing the video, participants are rating emotional valence from 0 to 8 and emotional arousal from 0 to 8. And what we're going to do is we're wanting to screen for a one-way ANOVA model where we're looking at evidence for population differences in valence and arousal across our different racial ethnic groups in this study. So, have this data open here. Here's our data set. You see we have our participant number, our racial ethnic background here, and then ratings, again, 0 to 8 for emotional valence and emotional arousal. Okay, so what I'm going to start by doing is I'm going to run an egen command. I'm going to generate a new command called check, and I'm going to tell Stata to calculate a number for all non-missing rows looking at ethnicity, valence, and arousal. What I want to do here is just run this as a quick check to see if I have any missing values in this set. So again, the egen is just recall a command to generate a variable. We're going to name this variable check, and we're going to say insert the value for non-missing data for ethnicity, valence, and arousal. So if I highlight that and run it, we see that we get my check variable, and so I've got values for 1, 2, 3 here, so we get a value of 3 for my check, and we just want to go through, and now we're going to sort by this check value, and we see that we have no missing data here. So this is just remember a nice way to go through if I'm running an analysis with multiple variables, a quick way to just go through and see if I have any missingness, particularly in a large set. Any value or any case that would have a missing value when I sorted it would end up showing up down here at the bottom. But we have full information, or we have full data for this set, so we want to make sure that we make a note of that and write that down. Okay. So what we're going to do now, because remember we have a grouped analysis here, we're looking at differences across 3 different racial ethnic groups in terms of their response to this standardized emotional stimuli. And so what we want to do is we want to get minimum, maximum values, mean standard deviation, skew kurtosis values specifically for each group. Okay. Now there's a couple ways we can do this. If you look at your handout, we could enter by sort by ethnicity, and our by sort command, remember, is just going to split our data file up and to give us our analyses specifically individually within all levels of my categorical variable. In this case, it's going to be ethnicity, and then I could just hit our general sum statement, valence, arousal, and then the detail specifier here is going to give us skew kurtosis, things along those lines. But I kind of like the tab stat command here better for this. It just lays it out a little bit nicer. So this is what I'm going to use here in the syntax file, or my do file. So I'm going to by sort by ethnicity, and that's going to just split things up across my 3 different groups, and then I'm going to summarize valence and arousal, and I'm going to request sample size, min, max, mean, standard deviation, skew, and kurtosis. Okay, I'm going to go through and I'm going to run that. And here, let me pop this up a little bit larger. Okay, here's what I get. So, for my white non-Hispanic group right here, I have 41 individuals. We already know we don't have any missing data, so that's good. Minimum, maximum for valence and arousal. Everything looks to be within reasonable values. Again, remember these are 0 to 8 scales, so everything looks good. Mean, standard deviation is fine. We're not too worried about that right now. But if we go down through, we look at skew, no real problems here. Skew negative 0.4. For arousal, it's about 0.03, so no concerns there. And then our kurtosis values. Remember that Stata gives us kurtosis values with a value of 3 being a neutral value. So here we can calculate this pretty easy. I mean, you subtract 4.66 and then subtract 3. That's going to give you 1.66. So that's pretty easy. Math here isn't too hard, but if we go display, remember this is just our kind of built-in calculator. We say our value minus 3. Okay, so this is going to give us a kurtosis value of about negative 0.52. So skew 0.3. Skew for our white non-Hispanic group, skew's good. Our kurtosis is 1.66. It's not too bad. Arousal skew is near 0. Kurtosis value negative 0.51. So nothing too much to worry about here. Same thing if we go to black non-Hispanic, 38 individuals. Everything looks to be in range. Skew looks fine for both valence and arousal, and kurtosis looks all right too. 2.51, 2.24. Again, if we wanted to get exact values, and we will, which is, we can just hit that, right? And that will just pop up our last command down here in our command log. Paste that in. Okay, so for our black non-Hispanic group, kurtosis for valence is negative 0.49. That's not bad. If I click that again, copy that down. Okay. Kurtosis value here is negative 0.76, so that's looking pretty good. And then finally, our heterogeneous other sample, smaller number of individuals here, but everything looks to be within bounds. Skew looks okay and acceptable for these means-based analyses. Kurtosis also looks like it's not too bad. If I want to calculate specifics, go through, highlight that, and then just display my kurtosis value instead of minus 3. So we've got kurtosis value of negative 1.2, suggesting kind of a boxy distribution here. Here, the kurtosis, we just subtract 3, it's going to be 0.07, near 0. So we'll want to go through, record our skew and kurtosis values, but in terms of our indexes, our index of our distributional indexes, our skew and kurtosis looks okay, particularly given the sample size across the 3 cells. So we're not too concerned here. Okay, so I'll move this back over here. All right, so looks like our descriptives aren't looking too bad, but we want to go through and we want to get some graphical representations here. So what I'm going to request first is a histogram. Okay, I'm going to request a histogram for valence, and here I'm going to say, I'm going to throw in some, I mean, we could go through if you wanted to. I could just go hist valence, and it's going to pop up. Now this is a histogram just for the entire sample, but it's pretty generic, and we want to remember split this up by individual groups. So what we're going to do is we're going to give it a little bit more elaborate language. So we're going to request a histogram for valence. We're going to specify our data as discrete, because remember we've got 9 different values this can take on, so we don't necessarily need to bin this. So we'll just tell Stata that this is a discrete variable. It only takes on a limited number of cases. On the y-axis, we're going to ask for, give it to us, ask us to make the y-axis in terms of frequency. Here we're just asking for the line color. This is just for the bars to be black, giving it a Y label making that horizontal. We're going to ask for groups by ethnicity, and then we're just going to name this variable or this graph H1, and then hit replace so we can keep running it if we need to. Now these forward slashes here, remember that this is just to carry our do file or command line over into the next line. This is just kind of like a pause or a break. We could do that and just run the whole thing. It just makes our do file kind of long. So what we can do instead is we can just hit /// and then just kind of do that, and then it'll run it for us. Okay. So what we're requesting again is a histogram for emotional valence, telling it to just bin it as individual categories as discrete, and then we're just, the main thing here is we're going to run it by ethnicity. Okay. So go through and run this. And here's our graph here. So again, we're just doing some things just to kind of make this look cute. Made our y-axis frequency. We give it black lines. Made our y label horizontal. So nothing, just kind of making it look good. But what we're interested in here is then going through and taking a look at our distributions. So we go through, and what we've looked at is each one of these separated by ethnicity. For our first histogram here, this is looking pretty good. Looks fairly symmetrical, but the majority of our values are falling at 4, 5, and 6. We've got this one value kind of hanging out separate from the rest of the distribution. This is someone who rated this film as being very low in terms of pleasantness, so that's kind of strange. We might want to make a note of that, but nothing that we're super concerned about here. Same thing with our black non-Hispanic participants. Again, same, most of our values falling in 4, 5, and 6 as before. Nothing too much going on here. And then we get down to our other category. Looks like distribution's kind of squarish. Looks like we may have some bimodal stuff, which we're not super surprised about, maybe, given that we've just this is a heterogeneous group, but nothing at least in here that's looking like that we would be concerned in terms of violations of normality or things, or excuse me, problematic violations. There's clear violations of normality, but nothing that would be, at least based on these graphs, looks like it would be problematic from the perspective of our analyses. Okay, so that's valence. We can go through and then we can just run the same graph. We're just going to swap out valence for arousal here and run this. And so again, when we're running our graphs, if we give our graphs a name, here this one's H1, histogram 1, and then the replace is just so if I wanted to run it again, it'll just run it again. If I don't put that replace, it'll tell me there's already a graph named H1 in the memory. So we've gone through and run that, and here's our histograms by group for emotional arousal. For a white non-Hispanic group, this looks beautiful in the normal, so that's good. Our ratings of arousal for our black non-Hispanic participants look to be kind of bimodal. Looks like we have a major mode at 2, a minor mode at 5, but something interesting may be going on here. Not problematic, but something we might want to think about a little bit. Here, for our other group, emotional arousal looks relatively symmetrical, with the majority of cases or scores falling at 4 and 5. Okay, so we just want to go through in our screening summary and just make some comments and describe what we have going on in our distribution or our histograms here. Okay, so those are our histograms, but we also want to take a look at box plots. Histograms can start looking pretty different depending on how we've been. Again, here, this discrete command and graph told it just to plot these as individual bars. But what we're going to do now, we're going to go ahead and take a look at our box plots. So again, we've got our graphing, our box plot of valence over ethnicity. So this is just telling it to create different graphs or different box plots across ethnicity. So we get our grouping value here. The marker one is we're just telling it to give our any outliers, make those markers small in size. Marker label is going to be subject, so we can kind of see who's falling outside 1.5 times the interquartile range, and then we're just naming this again. Okay, so if we go through and run this, here's our box plot. Things are looking pretty good here. This is our box plot for emotional valence across each one of our groups. For emotional valence for our white non-Hispanic group, looks fairly symmetrical. For our black non-Hispanic group, again, fairly unremarkable. I wouldn't even call this too much of a skew here. Our emotional valence for our heterogeneous other group, we look like we have our third quartile here, or excuse me, our median is up near the third quartile. So as our median is more towards the top of the distribution here, but otherwise no values falling beyond 1.5 times the interquartile range. So in general, again, in your screening write-up, you just want to go through and make sure that you're giving some description of what's going on in these box plots. But for the purpose of our screening, everything's looking pretty good here. Okay, so we want to do the same thing for arousal. So again, box plot for arousal over ethnicity. This is just going to break it up, telling it we want small marker size, small marker dots if something falls beyond 1.5 times the interquartile range. Marker label is our variable subject, so it'll just put names on there, and then we're going to name this B2. Okay, so we go through, run this, and then here we go. Okay, so here for our white non-Hispanic group, we notice that variability in terms of emotional arousal for this group is quite a bit smaller than our other two groups. So we've got within this group much more consistency in terms of general ratings. And again, if we go back as valence, we'll get rid of valence for right now. If we take a look at arousal, yeah. So, oops. If we take a look here, we say pretty much everybody's pretty tight here in the center, but then we've got some values up here and down here falling beyond 1.5 times the interquartile range. So another thing here that's interesting, we might want to note that the median and the third quartile are both at values of 4. So we might want to take a look at this. Looks like the most interquartile range runs from value of 3 to 4. Value of 5 is the most extreme values that's still within 1.5 times the interquartile range. Value of 2 on the low end. Value that's still most extreme value still within 1.5 times the interquartile range. And then it looks like we have some points above and below that are exceeding 1.5 times the interquartile range. Okay. Now down here, because in our box plot we said to label markers by subject, and so down here it looks like we've got one case 56 that has a value of 1 that's falling below 1.5 times the interquartile range. If we go to our data set and we'll go sort arousal. It's just going to sort it here, and so we can see well, here, let's do this. We'll go sort ethnicity and arousal. So it'll sort first by ethnicity and then by arousal marker. So we'll go through and do that. Okay, so all our white non-Hispanic folks are on top in order of arousal rating. Same thing as we go down here. So we're interested here in our white non-Hispanic group. So if we take a look here, looking at arousal, we see this is our one number, case number 56, has an arousal rating of 1 down here. So we'd want to make a note of that. Again, if we go through and take a look at our histogram, this isn't a case that we're going to be worried about. This is a beautiful distribution, but we will want to note on the box plot that this is still falling below 1.5 times the interquartile range for this. Now, if we go back up and take a look at our box plot for values falling above 1.5 times the interquartile range, looks like we have a couple of values here. It's hard to read because they're all kind of stacked up on one another. So this is why, again, if we go through and sort, first by ethnicity and then secondarily by arousal, what we can go down through is take a look. And so it looks like we've got 3 cases with values of 6, 162, 166, and 4, right? And looks like that's what's all happening stacked on top of each other right there, but would want to make a note of those values. Okay, so moving on, we've got our Black non-Hispanic participants. Looks fairly unremarkable outside of just having quite a bit more variability, going the whole range from 0 to 8 in terms of emotional arousal, but nothing too concerning in terms of the distribution here. For our other group, looks like maybe a little bit of negative skew going on here, but not too bad. Nothing in either of these, in any of these 3, is anything that looks like we might be too concerned about. Okay, so on our screening summary, wanting to make sure we've gone through and provided a description of each one of these, but otherwise things are looking pretty good. Okay, so I'm actually gonna close out here. All right. So last thing we're going to do here is going through and look at z-scores. Now, again, based on our histograms and our box plots, we already kind of know that we're probably not going to hit anything that's too terrible in terms of extreme values, right? Everything looks like it's hanging out together pretty tightly. We've got one value hanging out that's a little bit separated from the rest, but in general, things are looking good. But we still, for a screening summary, will want to go through and write down actual z values. So remember that to calculate z-scores by different groups, we've gone through and put together this small macro here. You can just paste this in. Remember that when you're using this macro, what you want to do is you're going to, after local target, you're going to put in your variable names, right? So here we're looking at valence and arousal. Your grouping variable is ethnicity, and then the level, right? So we've got our groups are coded white non-Hispanic is 0. You can see that up here. Our black non-Hispanic is 1, and our other group is 2. So the only thing we're going to modify in this macro is our variable names. So we've got valence and arousal. Our grouping variable is ethnicity, and then our min and our max for our grouping goes from 0 to 2. Going to put that in there. Once we've done that, everything looks good. Highlight the whole thing and run that. And then what we'll see here is that it's giving us the mean and standard deviation individually for each group. We don't need to worry about that too much. But if we go down through and we look at our, we've got now a variable for valence and arousal. But importantly, what this has done is it's standardized and given us z-scores for our white non-Hispanic group using the mean for white non-Hispanics and the standard deviation for white non-Hispanics, and then calculated z-scores and arousals, z-scores for valence, z-scores for arousal for that group. Same thing for our black non-Hispanic and our other group. And to check this and to see what we have in terms of maybe any extreme values, we're just going to, again, say by sort by ethnicity. This is just going to split up our files by our grouping variable. And here we're just going to hit summarize, z valence, z arousal. Going to run this. And here we go, right? We see that our mean values here are, this is 6.54 times 10 to the negative 9th, 10 times 10 to the 0, functionally 0, right? Unless you want to carry out 9 decimal places, we're not worried about that level of precision. So it looks like macros worked there. So we got mean of 0, standard deviation of 1 across each one of our groups. So it looks like everything's worked out. If we're looking here, again, we're looking for large absolute z-scores, so z-scores that are very, very big on the max or very, very small on the min. For valence, looks like within our white non-Hispanic group, we've got at least one individual with a minimum z-score of about getting close to 3 1/4 standard, or just above 3 1/4 standard deviations below the mean. That's technically something we'd probably want to take a note of. But max value, a little over 2 standard deviations for arousal for our white non-Hispanic group. A little over 2 standard deviations below, about 2 standard deviations above. Same thing here. Same thing here. Got a little low one here. It's negative about 2.4 standard deviations below the mean. Above, so really nothing too much to worry about. One thing we'll want to take note of is we got the one value here that's still at least notable. If we take a look at so this is our z-score for emotional valence for our white non-Hispanic group. If we go back through and we take a look, that's this joker right here. Okay, so what we can do then, if we hit sort, we'll go Z, there we go, ethnicity, Z valence, or just make sure, Z valence, drop it in there, sort those, and then we can figure out who's what. So yep, here it is for our white non-Hispanic group. Our z-score for our valence, negative 3.25. So this is case number 68. So we just want to go through and make a note that this person is someone with a relatively extreme score in the negative direction. This, again, is someone who was shown a funny film and did not rate this as being funny at all. We might want to go through and check our hard copies, make sure that this wasn't a data entry error, but it's a reasonable value. Not everybody thinks things are funny. So, but it's not probably going to be an issue statistically for us. Okay, so only other thing that we would want to do in terms of our screening for this one-way ANOVA would be to check our homogeneity variance assumptions, but we'll do that in the next video when we're actually running our actual analyses. So again, if we go back to our handout, all of this is documented here in the handout for you, and then finally the only last thing we would do is our write-up. So again, didn't have any missing data. All our values were within bounds, have a full set of 999. And then what we're doing is we're looking at our distribution specifically for our white non-Hispanic group, black non-Hispanic group, and other, noting sample sizes or cell sizes, recording values of skew and kurtosis, brief description of our histograms, brief description of our box plots, making sure that these are accurate representations of what we're seeing. Same thing for a black non-Hispanic group, our other group. Extreme values here. We saw a low value for emotional valence in one case. No extreme values for anything else for our white non-Hispanic group. Black non-Hispanic, no problems. Same thing our other group. Okay. When we get and run our one-way ANOVA, we'll check homogeneity variance. So we'll see that we end up having what looks like a violation of homogeneity variance for arousal, but we'll get to that in the next video. And then just our recommendations in summary here. Okay. So hopefully this helps navigate working through Stata on this. But do let me know if you have any questions on things. So thanks a bunch, folks, and we'll catch you in the next video.